Today's I can statement is I can multiply decimals by powers of 10. Our sample problem for today is Javier is helping his parents put up posters in their movie theater. Each poster has a thickness of 12 thousandths of an inch. How thick is a stack of 10 posters? 100 posters? 1,000 posters? So we're going to start with our cubing strategy, and we are going to circle all of our key numbers that we have here. So we have 1,000, 100, 10, and then our decimal are all our key numbers. Next, we are going to underline our question. So in this problem, we have more than one question here. We're going to solve, looks like 3 questions. So, sorry, that was pretty bad. All right. There we go. So our question is asking us how thick a stack is of 10 posters. Then we have to figure out how thick the stack is if we have 100 posters and then 1,000 posters. Our next part of our cubing strategy is to box any keywords that we have. So I'm going to box keyword each because that is one of my keywords. All right. Next, we have to eliminate anything that we don't need. So it's nice to know that Javier has a movie theater in his parents' house, but we don't need to know that. So we're going to cross that off. We're going to eliminate it. And last but not least, we are going to solve. So our problem here, we're going to start with our 10 posters. So let's figure out how thick a stack of 10 posters is. And we are going to multiply 0 and 12 thousandths by 10. So one way that we can do this is by just moving our decimals. So when we're multiplying by powers of 10 and we have a decimal, all we have to do is move our decimal to the right. We're moving our decimal to the right as many spaces as there are zeros. So here in the number 10, we have 1 0. So we are going to move our decimal over 1 place because we have, like I said, 1 0. I'm going to try my best to draw an arrow there. All right, so now my answer is going to be 1,200. As you can see, I don't really need the 0 anymore. I moved over my decimal place 1, so now it's right here. And all I did was rewrite in the answer. So 0 and 12 hundredths. Now we have to multiply to find out our thickness for 100 posters. So we're going to use the same decimal there because that is how thick the poster is. And we're going to multiply by 100. How many places are we going to move that decimal over to the right? Click submit when you're ready. Okay, we should have said 2 places because we have 2 zeros in 100. So I'm going to take my decimal and I'm going to move it over 1, 2 places. My new number now is, or my answer, I should say, my product, is going to be 1 and 2 tenths. Again, I can kind of get rid of these zeros now, but I have my decimal right here because I moved it over 2 places. Can you see that my numbers are getting bigger when I multiply by 10 or 100? If I'm multiplying by those numbers, I need to move my decimal to the right, which makes my number bigger. So that's important to know for later on. All right, last but not least, we're going to find out the thickness of 1,000 posters. All right, I want you guys to try this one on your own. So we know that we have 3 zeros here, so we're going to move our decimal over 3 places. I want you guys to choose which answer you think is our product for this answer. Sorry, guys. I want you guys to tell me what the product is for this problem. Go ahead and click submit when you're ready. Okay, so we should have, like I said before, we're moving it over 3 places, our decimal, 3 places to the right. So 1, 2, 3 to go along with our 3 zeros. My new answer should be 12. And you can put zeros after there, but you don't need to. So I moved my decimal right here, and now my new answer is 12. That is how thick a stack of 1,000 posters are. All right. You can also use patterns to multiply by decimals. So here we're going to multiply 3 63/100 by 1, 1/10, and 100th. So before, when we were multiplying by 10, 100, and 1,000, we were moving our decimal to the right. So our product was getting bigger. Now that we're multiplying by decimals over here, we're going to be moving our decimal to the left. So our answer is going to be getting smaller. And here we can kind of see the pattern. So we have 3 63/100 times 1. We know any number times 1 is always going to be the same. So 3 63/100 is our answer. 3 63/100 times 1/10. We take our decimal and we move it over one space to the left. So remember, now that we're multiplying by decimals, our number is going to be smaller. So we have to go to the left. So our new answer, 363,000. All right, and you'll see down here now we have 2 numbers after our decimal, 1, 2. So we moved over our decimal 1, 2 places to the left. But I don't have a number here, so that's why I have to add a 0. So in my answer, you see that I put a 0 in the 10th place because I had to move my decimal over 2 places, and I need a number there to fill that. Okay, so it's very important that you remember to do that. If you ever have to move your decimal over too many places and you don't have enough numbers, you have to add a 0. Okay, I want you guys to try this on your own. So find the product of 6 14/100 times 10 times 100 and times 10 to the third power. Before you guys do that, I want to know, what does 10 to the third power equal? Click submit when you're ready. Okay, we should have said 1,000. So remember, we did this our first unit this school year. Then when we see the exponent 3, that we would make sure that there's 3 zeros in our answer. So 10 to the third power is going to equal 1,000. So go ahead and fill out these answers and click submit when you're ready. All right, so let's start with our first one, 6 14/100 times 10. We know that this is not a decimal, so I'm going to be moving my decimal place to the right. I have 1 0, so I only have to move my decimal place 1 time to the right. My number goes from 6 14/100 to 61 4/10. See how I got bigger there? Because I multiplied by 10. All right, next I have multiplying by 100, so I need to move my decimal 1, 2 places. So I'm going to take that decimal and go 1, 2. My decimal now is after the 4, so my new number is 614. Again, if you put the decimal here and added zeros, that's fine. That's the same number. Or you can do it without that and just leave it as 614. All right, so now I see my exponent 3, so I'm going to move my decimal over 3 places. 1, 2, 3. Uh-oh, we ran out of numbers, so I hope that we all remembered that we have to add a 0 there. So my new number is going to be 6,140. I had to add my 0 there because I had to move my decimal over an extra place. Okay, again, you can add the decimal after and do 0, 0, or you can just leave it as a whole number. Okay, All right, now let's try one by multiplying with decimals. So remember, we are going to move our decimal to the left now because our numbers are going to be getting smaller. Go ahead and click submit when you are ready. Okay, so our first problem, 6 and 14, so we have the same number, 6 and 1400ths times 1. We don't have to move anything because any number times 1 is always going to stay that number unless you are multiplying by 0. So 6 and 1400ths is our first answer. Now we're multiplying by 1/10. We have to move our decimal place 1's place to the left. And my new answer now, or my product for this problem, is going to be 0 and 614 thousandths. All right. And last but not least, we're moving over 1, 2 places. 1, 2. All right. I'm going to write my 0, my whole number, or in my 1's place, I'm sorry. Then I have to add a 0 in my 10's place because I had an extra spot here when moving the decimal. And then my 614 right there. So that should be our answers for this. And you'll notice the pattern. If you can tell, you're just moving it over. Or however many numbers are after the decimal. Okay, so here we had 1 number after the decimal. We moved it over 1 place to the left. Here we have 2 numbers after the decimal. We moved it over 2 spaces to the left. All right, nice job today, guys.